Hello and welcome, everyone. My name is Dane Minke. I'm the Digital Marketing Manager here at Regenesis and Land Science. Before we get started with the webinar today, I have just a couple administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will focus on the essential role of QA/QC in vapor barrier installations. With that, I'd like to introduce our presenter for today. We are pleased to have with us Ryan Miller, Director of Land Science. Ryan Miller oversees the overall operations and strategic direction of the division, ensuring the successful design, installation, and implementation of vapor mitigation systems, including TerraShield, NitroSeal, MonoShield, and RetroCoat. He provides technical support, fosters collaboration, and drives advancements in vapor intrusion barrier technology. With extensive experience in the environmental consulting industry, he previously worked as a New Jersey licensed site remediation professional, focusing on brownfield redevelopment projects and specializing in vapor intrusion mitigation. In addition, Ryan managed client relationships and oversaw project execution on construction and brownfield redevelopment projects. Ryan Miller earned a MBA from Montclair State University and a Bachelor of Science degree in Environmental Science from Siena College. During his free time, you can find Ryan on a golf course. All right, that concludes our introduction. So now I will hand things over to Ryan Miller to get us started.
All right, thanks, Dane. And thank you all for joining today. So as Dane mentioned, we'll be discussing the essential role of QA/QC in vapor barrier installations. So I'll be using the term QA/QC or QA/QC plan, along with CQA, construction quality assurance, interchangeably throughout this presentation, because I know depending on where you are in the country and where you practice, the terminology may be slightly different. So for some of you, this material may be refresher, which is great. For others, perhaps material is new, some of it's new, maybe all of it's new. Either way, we believe it's a very important topic. So again, thank you all for joining. We have a fair amount of ground to cover, so let's jump in. So the agenda for today, why do we need QA/QC in the first place? Seems like a pretty good place to start as any. We'll touch on the importance of having a durable vapor barrier, outline some of the typical components of a QA/QC plan, and at least why we here at Land Science recommend. I think much of these components are commonplace in our industry. And then finally, I'll wrap up with some potential pitfalls to watch out for and briefly discuss a case study that highlights the importance of having a plan in place. So before I get any further down the road discussing QA/QC, let's set the stage for what I'm talking about in the first place. You're looking at a photo of TerraShield vapor barrier being installed on a project in California. So this is a passive vapor barrier designed and installed to protect the future occupants of this building from potential vapor intrusion. There are, of course, many ways to mitigate vapor intrusion, but for the remainder of this presentation, I'll be referring to vapor barrier installations on new construction projects. So what you're seeing here and the need to have them be installed properly. So we're now at the stage of needing to mitigate vapor intrusion at a new construction project. Where do you start? How do you know what barrier to install? There are a lot of options available. As some of you know, not all of these options are created equal. There are many different materials, different thicknesses. They're installed differently. Think tape versus spray applied. They're rated to work against different contaminants and different concentrations. So at Land Science, when we're evaluating our own vapor barrier products, we look at two very important criteria: chemical resistance and constructability. So chemical resistance, the ability for the barrier to block vapors, and then again, what we call constructability. It's really an umbrella term that encompasses how the barrier is installed, how durable the barrier is against construction, and then the overall quality of the installation. It's really the combination of these two factors that often determine which barrier is selected for any given project. So that first part, chemical resistance. Most folks are familiar with this topic and generally understand what's involved, right? Most regulators look to chemical resistance as their first stop in the evaluation process. And in our experience, most design engineers do as well, and for good reason, right? This is a very important aspect of the vapor barrier evaluation process. It's vital to have a vapor barrier that's been tested and has demonstrated its ability to block the contaminants that are at your site, right? However, just as important, and in our opinion, the most overlooked, is constructability. And constructability is a crucial component of the vapor barrier evaluation process, right? You can have the most chemically resistant vapor barrier in the world, but if it can't be installed timely or the seams can't be sealed together, how confident can you be in that system performing properly? So when evaluating the overall constructability of any vapor barrier, there are three factors to consider: the efficiency of the application, the durability of the membrane, and then the measures put in place to ensure a quality installation. Why do we need QA/QC in the first place? Well, I think the simplest explanation is that we're working on an active construction site. Look at this photo. You can see all sorts of activity: equipment, construction material, rebar, steel, different trades, all working at the same site at the same time. Let's take a step back and think about what we're actually trying to accomplish. The goal is to install a properly functioning vapor barrier designed to protect the building from potential vapor intrusion. So doing that at the same time that they're building this building. And those two things are contradictory, right? They do not necessarily align. So the need for a vital, proper QA/QC process throughout that installation is needed. And if we take a closer look at what is actually happening on the ground, there are many obstacles and situations that we as the vapor barrier installation team need to contend with. So as an example, forms and rebar, right? These can significantly impact a vapor barrier installation. The rebar used for reinforcing concrete can puncture, damage the vapor barrier. The chairs used to support that rebar need to be placed carefully to prevent the sharp edges from damaging the barrier. The concrete forms may also create stress points or cause shifting that can lead to tears or movement in the barrier. So adding to the complexity of all this is that these components of the building construction are being handled by different trades. So ensuring proper attention to all these factors is very important. Another example of what's happening on the ground is working and installing the vapor barrier system around utility penetrations, pipes, conduits, penetrations that are passing through the vapor barrier and the concrete slab. So these penetrations present critical points of potential vulnerability for the vapor barrier and need to be carefully addressed. So penetrations can create VI pathways if they're not properly sealed. So it's always important to pay special care to these areas. Another example of why QA/QC is so critical is even once the barrier is installed, equipment and vehicle traffic during construction can pose significant risks to the integrity of the vapor barrier. The weight, the movement of machinery can puncture, can tear, can move the barrier. So to mitigate these risks, protective measures can be used. Things like covers, geotextile, protective boards can all be installed in the high traffic areas. Proper communication, coordination with the construction team are essential to minimizing unnecessary traffic across the barrier. So barriers with higher puncture resistance and tensile strength, which I will touch on in some of the upcoming slides, are better suited to withstand incidental contact from that equipment. So again, implementing these precautions can help preserve the barrier's integrity during construction. The last example I'll showcase is what we call the dreaded tenant fit out, which unfortunately happens all the time. So even if you follow your QA/QC plan accordingly, the vapor barrier was installed properly, the concrete was poured, and the building was built, you can still have potential challenges down the road when modifications are needed to accommodate tenant-specific needs. plumbing, electrical, your tenant needs to install a new bathroom over here or is adding a kitchen over there. All of these things could potentially involve cutting or penetrating the slab. So that can pose a risk to the vapor barrier. So in the upcoming slides, clear documentation of the barrier's location and proper repair protocols are very important so that future modifications do not compromise the vapor barrier itself. So now that we know all the things that can impact the vapor barrier installation, which again is a lot because that list I just shared were only examples. Let's talk about things you can do, things you can control, with the first being durability of the vapor barrier. So selecting a quote unquote durable vapor barrier is obvious. It seems obvious, but what does that actually mean? How do we evaluate it? What goes into a durable vapor barrier? Thickness certainly adds to its durability. So the thicker the barrier, the more it's able to withstand construction-related activities. If you add a geotextile fabric to the underside of the barrier or on top of the barrier, that will certainly make this entire system more durable. What about how the seams are sealed? I'll address this point in much more detail coming up, but the seams of the vapor barrier liners and how they are sealed could potentially make or break in some scenarios the success of the entire vapor barrier system. So when evaluating vapor barrier products, the technical specification lists certain physical properties, things like tensile strength, elongation, puncture resistance. And I think for the most part, people see those listed, they see an associated value, but I don't know that they really put together what it all means and why those certain parameters are tested and provided on the technical data sheet. And it's again because we are working on an active construction site, right? Tensile strength, elongation, puncture resistance have real world implications when installing vapor barriers. Let's take a closer look at tensile strength. So this is the ability of a vapor barrier to stretch without breaking. Think how well it accommodates movement in the soil, the building, or during the installation. As an example, the photo on the right is showing a vapor barrier that's terminated to the perimeter wall. Now, if there was pressure applied to the vapor barrier by, say, equipment or something else, there would be a pulling at that termination point. You also see a list of standards on this slide, and these are just provided as an example, but the takeaway is that there's not one correct method. And these methods, or I really should say the values derived from these methods, can't be compared apples to apples. These methods are specific to barrier material that is being tested. So as an example, you can have a thin plastic sheet versus a composite vapor barrier with a fabric. Those two materials are different and they'll have different ASTM methods and thus different tensile strength values. We get asked all the time, why don't we have a certain ASTM method? Why does this manufacturer not have a certain ASTM method? And again, the answer is because those methods are specific to the type of material that's being tested. Now, taking a look at puncture resistance, everything I just said about tensile strength applies to puncture resistance as well. There are a lot of quote unquote accepted methods, and again, they aren't comparable apples to apples. With that said, puncture resistance is the ability to withstand damage or penetration from sharp objects at pressure at a constant speed. So imagine these guys on the right dropping a hammer or a piece of rebar. Puncture resistance measures how well the vapor barrier can withstand that type of force. These really are real world scenarios that happen all the time. Trust me when I say the other trades, the other workers, they have one thing on their mind, and that is to focus on their job. They don't care, and not necessarily in a bad way, but they don't care about the vapor mitigation scope, and they have very little concern for the vapor barrier itself. So the vapor barrier you're installing will be subject to some gnarly stuff. So please consider taking a closer look at puncture resistance and tensile strength and other physical properties because it ultimately does matter. The upcoming QA/QC plan that I'll discuss tries to mitigate a lot of these actions, but selecting a barrier that can handle the construction site will certainly give you a leg up. So just to recap this topic, understanding that ASTM methods are specific and that there's no single ASTM method available for every type of barrier. Tensile strength, puncture resistance are connected to much of the installation process. As an example, subgrade materials that are above or below the barrier, puncture possibilities from rebar, the contractors working on it, on the barrier, concrete trucking, pouring sequence, potential differential sediment below the slab. The takeaway here is that there's no one barrier that fits all scenarios. That's why, as an example, we at Land Science offer various vapor barrier products because each project has different requirements, has different needs, has different priorities. That's why we always recommend you connect with the barrier manufacturer and the design engineer to discuss what options are available. Okay, let's take a pause. We've discussed why we need QA/QC in the first place. We've talked about how we can put ourselves in the best position to have a successful installation in terms of vapor barrier durability and why that's important. And this is the final piece to the puzzle: construction quality assurance, or the QA/QC plan. In our hypothetical project here, the vapor mitigation design is completed. The vapor barrier perhaps is selected. Everything listed here can help ensure the project goes smoothly and occurs as designed. So manufacturer review, talking to people like me for a peer review. And I'll go into detail on all of these topics. Pre-construction meeting, I think this one's fairly self-explanatory. Using a certified installer, having a third-party inspector on site, completing thickness verification and smoke tests during the installation, conducting a final pre-pour inspection and a site visit during concrete placement. These are all things that should be included in your QA/QC plan. So manufacturer peer review. That could be anything from answering questions about venting layout, helping create custom construction details, reviewing analytical data to ensure compatibility with site contaminants. All of that can be part of this peer review. My recommendation is take advantage of the historical knowledge and expertise that the project team brings to the table. Pre-installation meeting. When talking to our certified installers, design engineers, even the general contractors who typically don't know much about the vapor barrier installation process, they all say the pre-installation or the pre-construction meeting is the greatest bang for their buck. It seems like an obvious thing to do, but being part of so many of these meetings, some of them are done really well and others not so much. Just having a chance to review responsibilities, scope, the anticipated time frame of certain scopes, discussing contingencies for weather, other unforeseen situations will do wonders for the success of the installation. Certified installers. Land Science believes experience matters, proper training matters, having vapor intrusion knowledge and know-how matters. That's why we require a certified installer to install all of our vapor barrier projects on every single project. I can't or won't really speak to what other vapor barrier manufacturers do, but we know utilizing contractors that do this day in and day out makes sense on so many different levels. Why would we trust a different trade, like a concrete subcontractor, to install a vapor barrier? It's not in their wheelhouse and frankly, not their priority on the project. Third-party inspectors. These are the guys keeping records. So these folks are on site to observe, keep notes about the installation. This means taking pictures, recording site conditions, detailing pre-pour conditions, observing the smoke tests. This is not only good practice and highly recommended for all projects, but it is a requirement for some in order to qualify for extended warranty options and or to meet regulatory requirements. So as a quick aside, Land Science offers an online training course, which is free to take, usually takes about an hour to complete. It's found on our website, so feel free to utilize that feature. Here's an example of a testing log that the third-party inspector will typically use during their inspections. Again, recording all of this applicable information that's listed. The form is super helpful for those that will be on site, even if they're not officially completing a third-party inspection. Just using this form as a guide is really good practice. Thickness verification. So for composite vapor barrier systems that utilize spray applied core, as you can see in this photo here on the left, thickness verification is literally confirming the thickness of that spray applied core in real time. So the material is sprayed out across the building footprint and coupons are cut out of the barrier. So these coupons are measured. You can see the picture on the right there, which will confirm that the thickness prescribed is the same as what they're seeing in the field. So that could be 30 mil, 40 mil, 60 mil. Those coupon locations are easily repaired after the fact. Again, this is such an easy and efficient way to confirm the vapor barrier is being applied as per the design in real time. And that's the key, in real time. If the coupons are measuring too thin, additional material can be applied, again, in real time. Smoke testing, another absolute critical aspect of any QA/QC plan. There's no better way to confirm a true vapor tight seal at the seams, the penetrations, the perimeter termination than by completing a smoke test. This again allows you to see, again, in real time, if the vapor barrier has been installed properly and if repairs are needed at some of these critical pathways. So for anyone unfamiliar, a smoke test is when smoke gets pushed underneath the vapor barrier, which then allows you to see if smoke is escaping from any of the areas that weren't properly sealed, typically around utility penetrations, as you can see on the photo on the right. So the photo on the left, you're looking at smoke being sent underneath the barrier. And then on the right, this is an example of where additional repairs would be needed because smoke can be seen exiting near those utility penetrations. The smoke test is critical because I've personally witnessed plenty of installations where everything looked great during the install. Excellent spray coverage, good seam closure, tight wrap around the penetrations. And as soon as they start blowing smoke under the barrier, it's revealed several leaks that require attention. So these were easily fixed, but without a smoke test, everyone would have assumed that vapor barrier was good to go. So it's not unusual for projects to have hiccups along the way, right? It just comes with the territory. Thinking back to all the reasons why we need QA/QC in the first place, I'll just touch on a few pitfalls to watch out for. The first being taped vapor barrier systems. If you talk to most of the certified installers out there who install all types of barriers, spray applied, tape systems, they typically do not like working with tape vapor barrier systems. And these photos, I think, are an example of why that is. The photo on the left, probably a bit of an exaggeration. And if you see this scenario, your project probably has bigger issues. The photo on the right, though, seems fairly plausible. It seems like a very realistic scenario. Tape requires clean conditions, dry conditions to work as designed. Think back to those original construction photos that I shared, and I think you'll quickly realize that clean conditions don't exist. You'll very much likely end up with something similar to the photo on the right, where it looks kind of decent, but upon closer inspection, those seams are not vapor tight. And if you try to smoke test that, well, you're not going to be successful. So I know many installers who will refuse to complete smoke tests on tape vapor barrier systems because they can't complete the tests in an efficient manner. It just takes too long. It's too hard to pass a smoke test. And then making all those repairs takes too long. Here's a side-by-side photo of a taped vapor barrier on the left versus spray applied vapor barrier system on the right. And I think these photos speak for themselves. So another pitfall to watch out for is the construction activities, or really the sequencing around the concrete pour. This can be a kind of a forgotten area because it's happening after the vapor barrier has been installed, but it's critical to keep in mind that one, the form stakes can't puncture the barrier. And if they do, which we again advise against, they need to be properly sealed and repaired. As I spoke about earlier, getting the concrete down by either pumping or dumping from a truck can pose serious concerns for the vapor barrier. So ensuring that this has been discussed with the project team prior to is a huge piece of advice. I've been on countless conference calls trying to figure out a path forward as you can hear a concrete truck backing up to the pour location. I recommend not being in that position. Another pitfall, and this one is essentially the entire point of this webinar, I guess, but choosing the right product for the right site. Oftentimes, if chemical resistance is the first and only thing considered, you can end up with a product that will work against the site's contaminants, but it won't work for the building's foundation. So think about the difference between this photo that has a lot of underground utilities and other foundation elements to deal with versus a slab on grade warehouse. Again, knowing all aspects of the project prior to will help you make better decisions when selecting an appropriate vapor barrier. Okay, so the last pitfall that I'll discuss is weather. Something we all have to deal with, and for the most part, we all kind of dread. Cold, windy, wet conditions will certainly impact a vapor barrier installation. As I mentioned during the pre-construction meeting, having contingencies in place to handle weather impacts can help ease the pressure or concern. It won't eliminate your headaches, but it will certainly make the next steps much easier. Always default back to the manufacturer to know how their product will work in bad weather, whether that's rain or just really cold weather. I'd also recommend utilizing the experience of the certified installer. These guys have worked through almost all conditions and have certain ways to get things done. With that said, let's take a closer look at an actual case study. So we affectionately call this case study the bomb cyclone. And for anyone wondering, yes, this is an actual weather term. Apparently, a bomb cyclone is a fast developing storm where the pressure drops incredibly fast, causing heavy wind, rain, snow, who knows what. And we experience this. So we highlight this case study for two reasons. One, to show why durability matters, especially seam durability. And then two, why having a QA/QC plan is needed, or why having a QA/QC plan is so important. So this project was several 100,000 square foot warehouse development project where MonoShield was the vapor barrier that was being installed. You can see in this photo here, MonoShield is a single sheet vapor barrier where the sheets are seamed together using a spray applied core material. So MonoShield has become increasingly popular for these types of projects because it's fast to install, incredibly chemical resistant, and durable enough to withstand this type of construction and weather, as you will see. So the sequencing of this project essentially called for MonoShield to be installed with the concrete pour following right behind it. Basically install 20, 30,000 square feet, and then the concrete pour would follow either much later that night or the next day. And this would continue until the building slab was complete. So MonoShield was installed, and that night, apparently a bomb cyclone hit the area with basically no warning. And this was the result. So the vapor barrier was blown out of place, twisted up, more or less unrecognizable. This, of course, caused a whole bunch of concern from the project team. Everyone assumed that vapor barrier would need to be replaced, further delaying the concrete pour schedule, further delaying the project, costing the project a whole bunch of money. Here's why durability matters. You can see from this photo, the vapor barrier was not damaged by the storm. And in fact, all the seams stayed intact. This photo, I think, does a really good job showing how well the spray applied seams hold together. Now imagine using a thinner plastic vapor barrier or vapor retarder that was taped together. I can't imagine that type of vapor barrier would look the same as the photo you're looking at. The certified installer was able to unravel the vapor barrier, put it back into place, saving countless days, countless amount of money trying to put a new entire system in. Here's why having a QA/QC plan makes all the difference. The certified installer was able to follow their plan, redo their smoke tests, ensure all the seams and termination points were not damaged. The third-party inspector was on site to oversee this. They provided pre-pour inspections to confirm that everything was done accordingly. So this crazy type of weather event and the corresponding outcomes could have caused serious issues for this entire project team, the project ownership, had they not used a vapor barrier that was durable enough to withstand not only the construction, but also a freak weather event. So some takeaways to put this all together. No matter the system being installed, ensure that there is a QA/QC plan in place and make sure it makes sense for the specific project. A poorly installed vapor barrier defeats the entire purpose of installing a barrier. Remember, constructability is equally as important as chemical resistance. Make sure your project team cares as much as you do about the outcome of the project. Utilize the experience of a certified installer rather than one of the trades who claim they can fit this scope into their proposal. I'll end with this picture. This is a picture of a monoshield installation at a large logistic warehouse development. I think this project shows that a vapor barrier can be completed efficiently, cost effectively, and most important, correctly when you have the right team in place. A team that follows regulatory guidance, manufacturer specifications and recommendations, and again, most importantly, follows a proper QA/QC plan. If you want to learn more about any of the vapor barrier systems that we offer here at Land Science, TerraShield, NitroSeal, MonoShield, feel free to contact me directly. I'd love the chance to talk to you in detail. Here's my contact information, and I'd be happy to answer any questions you have.
All right, thank you very much, Ryan. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple quick reminders. First, we will be sending out a brief survey after the webinar. We really appreciate your feedback, so please take a minute to let us know how we did. Also, you will receive an email with the recording as soon as it is available. All right, so let's circle back to the questions here. Ryan, the first question is, do most of your projects include the installation of active or passive venting?
Yeah, so I didn't actually touch too much on the venting portion of a vapor barrier installation. So much of that will depend on the design that's completed. But yes, for the vast majority of projects we work on, there is a subslab venting system that is installed below the vapor barrier. So the installation of that venting system is typically included within the scope of the certified installers. And that installation will fall underneath a lot of the same QA/QC plan that I outlined. That is just another extension of the entire mitigation system implementation. So yes, to answer your question, we certainly see venting installed on 80, 90% of our projects.
Okay, thanks, Ryan. So here's another question, and it is, does it make sense to place a protection layer of sand or gravel above the barrier for protection prior to installation of concrete?
Good question, and I will answer that with, of course, it depends. For the most part, vapor barriers are designed to have the concrete poured directly on top of them. There are some scenarios, some projects, some design engineers who like to put material on top of the vapor barrier as a protection course, as this question is alluding to. It ultimately comes down to a cost benefit analysis on the cost to put additional material down, get it installed on top of the barrier. So again, it depends on what the goal is for the project, what the priorities are, where the costs need to be either saved or where they can look to spend additional money to make the construction easier. So we have seen on certain projects them putting down a protection course. But again, most vapor barrier systems are designed to have the concrete poured directly on it.
All right, so this one is a two-part question, and it is, if the vapor barrier does become damaged, can it be repaired? And then second part of that question, is this the same for the tenant fit out situation you spoke about earlier, or is there a different process?
So the beautiful thing about a spray applied vapor barrier system is repairs are relatively straightforward and easy. You can make repairs again in real time, as you saw some of those photos where they're spraying the core material. If something is damaged during the implementation of the vapor barrier system, they can go back and make repairs in real time as that's happening. The repairs are relatively easy to do because, again, they're spraying additional material down on top. You're not trying to tape together seams or tape together spots that have been damaged. The spray works a lot more efficiently. The repair sequence for tenant fit outs is ultimately the same. However, as you can imagine, and you saw from that photo, it's a much bigger headache to get access to those areas. So if you can imagine the concrete slab for any building, if they're trying to put in new plumbing or installing new electrical conduit or whatever it may be, they're only saw cutting out enough to get those utilities in place. We, as the vapor barrier manufacturer, the design engineer, would certainly agree with us, as do our certified installers. We want more access to the vapor barrier in those scenarios to get the repair done properly. So it becomes a little bit of a push-pull scenario on the tenant fit out, just as far as access goes, because you have a building that's already essentially built. But the repair itself is the same.
All right, thanks, Ryan. So here is another question here, and it is, what is the cost to implement the QA/QC plan that you outlined, or is it all included?
Yeah, that's a really good question, and I didn't touch on cost much. So almost all aspects of that QA/QC plan should be included with the overall cost of the implementation of the vapor barrier. So if you're, a project team and you're getting a proposal from a certified installer, the things like the smoke test, the coupon sampling, the pre-construction meetings, those are all included. That is what is part of our entire process of installing a vapor barrier. The one thing that I will say may carry an additional cost is getting third-party inspection out on site. That is just typically something that is carved out of the vapor barrier installation proposal. So everything else that we outlined is part and is included in an installation of a land science vapor barrier.
All right, thanks, Ryan. So here's another question. You mentioned smoke tests. Do smoke tests fail often?
Yeah, that's an interesting question. As you saw in that photo, smoke escaping around the utility penetrations. And for the most part, that is a fairly common occurrence. Maybe not to the level that you saw in that photo. We use that photo as an example, but there are certainly one or two handful of locations on any given project that have smoke coming out of it. And again, some people would say that is a really good thing. You are now seeing where repairs are needed, but two, that the smoke test is actually working, right? If you don't see any smoke coming out of anywhere, then the question arises like, hey, are we getting enough smoke underneath? Is it reaching certain areas of the building footprint? But if you see smoke coming out of certain areas, well, one, that the test is working, and then again, in real time where repairs are needed. So it feels like it shouldn't be a good thing, but it ultimately is a good thing to see some areas that need repair. And again, the whole point is to be able to make those repairs in the time when you're in the field completing it, rather than down the road somewhere where there's a potential issue. So again, somewhat common, but ultimately a good thing.
All right, thanks very much, Ryan. So that is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you would like to learn more about vapor intrusion mitigation technologies from Land Science, please visit landsciencetech.com. Thanks again very much to Ryan Miller, and thanks to everyone who could join us. Have a great day.